Hey, Joe here from AWS. Today, we're going to be welding with E6010 and E7018. We're going to cover some essential tips and tricks to get quality welds. Remember, with any welding process, we always want to be in a safe environment and utilize the right PPE. All right, so we got two electrodes here, E6010 and E7018. Let's talk about the difference between these two popular electrodes. We got E as an electrode, 60, which is your tensile strength in thousands, so 60,000. We got the 1 here, which is all positions. And then we got the 0, which is the flux composition. In this case, it's cellulose based, and it's also indicates the polarity in which the electrode can be used. Having a look at the 7018 here, we got E as an electrode again, the 70 in KSI, or that's 1,000, so 70,000, a little bit higher than the 6010. And then we got the 1, which is again all positions, so you can do horizontal, overhead, what have you. And then you got 8. And that is indicating a low hydrogen and also the polarity in which the electrode can be used. Now, low hydrogen, that 8's a pretty important number because it really talks about what this electrode can be used and how you kind of have to treat it. So it's a little special. It's not quite like a normal electrode that you can leave hanging out. We have to maintain a certain atmosphere and a certain condition for it to get acceptable and quality welds. So really important to keep that in mind. All right, we're going to start with the E6010 electrode, but the first thing we want to do to get a quality weld with any electrode is prep our material. And to do that, we're going to take this grinder here with an abrasive wheel on it, and we're going to knock this mill scale off and get down to the raw iron. All right. So the E6010 electrode, a little bit more forgiving. It can be manipulated quite a bit more than the E7018. Here I'm actually applying a little bit of a circular motion. The arc characteristics are quite a bit more aggressive, so it wants to dig into the material a little bit more. This really is a pretty friendly electrode to work with in some coarse environments. So really feel free to apply any type of motion, whether it's a circular, a back and forth, a little side to side, whatever you feel that you can control that arc with the best, utilize that. So the 7018 electrode, you'll notice, is quite a bit more forgiving in the way the arc is digging into the material. It's a little bit smoother, a little bit more visibility. We really want to maintain slight motions with this, as it is susceptible to getting slag interworked into the molten weld pool. So maybe a little bit of side-to-side motion, if any at all. Here I'm just dragging it and maintaining a travel angle of about 30 degrees and trying to keep my work angle nearly perpendicular. You'll also notice that the slag coating is quite a bit different than the 6010. There's a different compound used in the 7018 flux, which is going to give the slag characteristics a little bit different appearance. And you'll kind of see when we remove it, it's a little bit easier to remove, comes off in bigger pieces. So we'll take that off here. Again, same thing, chipping hammer and a brush. You see, not a whole lot of work, but the profile of the weld is fairly smooth. It's very tight, pretty uniform. And that's what we're after right there. So here we got an E6010 and an E7018 stringer bead side by side. You notice after we remove the slag and hit it with a wire brush, the profile of the welds are similar. You may notice the E6010 has a little bit of a stepping or ripple effect. This is from a circular motion. This can be applied in different styles and types of motions can be applied to that electrode. You notice over here with the 7018, it's a little bit smoother. It's very clean along the edges. This is because we're just giving it a little bit of a drag motion, not really trying to manipulate the arc, again, because we do not want to have slag overlapping into the weld bead itself. So very common to keep a nice tight arc with the 7018 and try and limit any motion at all. These are both stringer beads here, and basically the stringer bead is a narrower weld, not going much wider than the diameter of the electrode. And these are the profiles we're after. Convex profile with a uniform toes of the weld here. And what we're looking to see is there's no gouging or undercutting along each edge, and none is present. So these are acceptable welds and something we'd like to see and produce over and over again. 6010 here, commonly used for a root pass. 7018, commonly used for a cover pass. Got 2 coupons here. I'm gonna show you what that looks like. All right, so I'm gonna tack this here, 6010. Actually got a half electrode, so I'm gonna try to use that up. What we're gonna do is just put a little tack here, jump the arc from the bottom plate up to the top plate, kind of keep a tight angle, try to drive that tack weld in there. I'll flip my hood down, I'm gonna throw an arc on it. Gonna go ahead here, throw a tack on the other side, just to reinforce it a little bit. And when tack welding, we're just gonna build a little pool and try to breach that molten puddle from the top plate to the bottom plate. All right, so here's the finished product. We got the E6010 root right here. Did a little step and pause motion. Really just tried to tie in both pieces of material. Again, remember E6010 is a very, very aggressive and penetrating electrode. So we want to make sure we get the fusion of those 2 pieces of material and good penetration in that root. We came over the top of it here with 7018. You notice the profile of the weld's quite a bit smoother. When we ran that, not much motion at all with the electrode, just kind of a drag and a little bit of maybe side to side to keep a uniform width as we went across. In tandem with these 2 6010 and 7018 welds here, it's a very common practice that you might see in any AWS welding procedure.